Hey guys, in this video, I'm going to go over how to evaluate powers of I. This topic often shows up on the ACT. So I is the square root of -1. That's the value of it. And so I want to talk about what happens if we raise I to a power. So if I have I squared, what we're doing for I squared is we're taking I squared, which is the square root of -1 squared, right? If I is square root of -1, then I'm just taking that and squaring it. Well, if you square a square root, those are inverse operations, you're left with just the inside. And so then I squared is going to be -1. All right, so let's think about, well, what's going to happen if we raise it to the third power? All right, well, that would be I to the third is really just I squared times another I. Exponent rules tell us that if we are multiplying with the same base, we add the exponents. So that would be a 2 and a 1, really. So this, if we already know what I squared is -1, then it's just -1 times that I, which is going to give me -I. All right, so I to the third is going to be -I. All right, well, let's think about what happens when we do I to the fourth power. All right, well, I can break down I to the fourth power as I squared times I squared, because 2 plus 2 is 4, and that is just -1 times -1, which is +1. Okay, now something cool is going to happen after this. Let's talk about I to the fifth power. All right, so I know exponent rules means that I can take I to the fifth power, and I am going to break it down as I to the fourth power times I, because that's 5 I's total. And I already know that I to the fourth power is 1. And so this just becomes 1 times I, which leaves us with I, which brings us back up to the beginning. Okay? So look at how this happens with I to the sixth power. All right, we have I to the sixth power. I could break that into I to the fourth power times I to the second power, which is 1 times -1, which is -1. So see how the list is repeating? If we did I to the seventh power, it's going to end up being the same as I to the third power. It's like you take 4 of them away if the cycle repeats every 4. And so then that's just -I, and I'll show you where it came from. If I wanted I to the seventh power, I'm going to break it into I to the fourth power times I to the third power. And so that means this is just 1 times I to the third. So it's whatever I to the third is, which is -I. And it just keeps going. Then when I do I to the eighth power, I bet you're guessing it's going to be 1, because we're repeating that cycle again. And so when I go to I to the eighth, if that's I to the fourth times I to the fourth, then that's just 1 times 1, which is 1. And so this cycle of 4s is going to repeat. So this is how we're going to do larger than these single digit numbers. Let's say I gave you an example of I to the 12th. What you're going to do is you're going to see how many cycles of 4, the power of 4 is going to go into that. So I'm going to, up here, I'm just going to do 12 divided by 4, and that gives me 3 with a remainder of 0. That means there's 3 sets of these 4, that cycle of to the fourth power. So I could rewrite this as I to the fourth times I to the fourth times I to the fourth, which is 1 times 1 times 1, which is 1. So when you get to I to the fourth, this is really like I to the fourth is really your first remainder 0. And so as soon as you get a remainder 0, then the answer is just going to be 1. All right, so let's try some other ones. Let's say I wanted to do I to the, let's say, 21st power. Okay, what I'm going to do is I'm going to do 21 divided by 4. Here, I'll work it out old school. 4 goes into 21 5 times. That's 20. Take it away. You're left with a remainder of 1. All right, so I'm going to look at my list and think which would be a remainder of 1. Well, that would just be I. I is just is just a remainder of 1. 4 goes in 0 times with 1 left over. And so then the answer is going to be I. It's the same as I. And if we wanted to work it out the long way, that would be I to the 21st is equal to I to the 4th, I to the 4th, 5 of them, right? Because it went in 5 times with 1 more I at the end. And so that's why it's equal to I. So you're just trying to figure out what your remainder is, and then it matches up with that cycle of those first 4. So if I was going to do, let's see here, I to the 38th. Okay, if I want to do I to the 38th, I'm going to take 38, I'm going to divide it by 4. I know 4 times 9 is 36. I'm going to subtract it, and I get a remainder of 2. So I'm going to look at my list. That would just be I squared. This is going to be equal to I squared. And then my answer is negative 1. And again, it's because I could have written it out as I to the 4th 9 times, and then I to the squared, I squared on the end. So whatever your remainder is, like, becomes your power. All right, and then you just use those that we already knew. All right, so let's see if I had I to the 47th. Okay, if I have I to the 47th, I'm going to do 47 divided by 4. That gives me 11 on the top because 11 times 4 is 44. I'm going to subtract. I get a 3. It's remainder 3. That means this is equal to I to the 3rd, which is negative I. So that is really what you do. Let's do a ginormous one. Let's do I to the 225. All right, so let's see if I can work this out. 225, I know 4 goes into 25 times, so take away 20, it's a 2, bring down my 5. And then it goes into 25 6 times, which is 24, and I'll subtract it and get remainder 1. So if I went remainder 1, that would be power of 1, which is just I. And that is how you work it out. Hope this helps.